Your smile as sweet as honey. Honey? Yeah, that is what I want to talk about today. I have conducted a scientific research on antibacterial activity of Malaysian Trigona honey, or known as kelulut honey, against bee licheniformis and also E. coli. Oh, by the way, my name is Nafisa Ilani Binti and my supervisor, Mr. Muhammad Shukri bin Nur Azman. Let's start with overview of this presentation. Background of this study: honey is a natural material that has recently gained popularity due to its potential therapeutic value. Besides, honey is marketed as a functional food with health-promoting characteristics that are scientifically and clinically validated. So what is the problem that we have to encounter? So the problem statement of this study is antimicrobial resistant. It is the most bacterial infections to current antibiotic and the escalating expense of finding effective antimicrobial drugs. In recent years, the quest for an effective solution for infectious illnesses has accelerated attempts to identify novel medications mainly from natural sources. Next is purpose of this study. First, to determine the antibacterial activity of Malaysian Trigona honey on Bacillus licheniformis and also E. coli. Besides, to specify the MIC of Malaysian Trigona honey towards B. licheniformis and also E. coli. And lastly, to determine the MBC, minimum bactericidal concentration of Malaysian Trigona honey against B. licheniformis and also E. coli. What is significance of this study? So, the significance of the study is the antibacterial properties of Trigona honey are the subject of this investigation. It is difficult to find materials with antibacterial properties that are similar to the way medicine works. So, this research project helps to prove the antibacterial activity of honey on test microorganisms, which is B. licheniformis and also E. coli. So, the findings of this study will help to find a solution to the unavailability of antibiotics based on natural products. Additionally, there is limited information on the antibacterial capabilities of honey and propolis derived from Trigona that are available in Malaysia. Show you the overview of the literature review that consists of stingless bee, Trigona honey, uses of Trigona honey, chemical constituents of Trigona honey, and also microorganisms. Stingless bee. What is stingless bee? Stingless bee can be classified into two genera, namely Meliponini and also Trigona, as described by Yap and Chin 2019. The specialty of the stingless bee is the ability to pollinate small-sized flowers due to their diminutive figure, which cannot be achieved by the relatively big honeybee. Furthermore, stingless bee also play an important role in the ecology, economy, and also culture. Besides, the stingless bee are not choosy in building a colony hive. As a result, it is easier to build an artificial hive to manipulate the colony and increase the honey production. Trigona honey. The picture in the left shows the Trigona honey species. It is multifloral honey from stingless bees, and it obtained its name from the bees producing it, and that are locally known as kelulut. Kelulut bees are from the genus Trigona, which is the largest genus of stingless bees. There are many uses of Trigona honey. Traditional Malaysians have utilized stingless bee honey, also known as kelulut honey, for anti-aging, improving libido and immune system, destroying bacteria, treating bronchial plaque, and soothing sore throat, cough, and cold symptoms. Besides, stingless honey is also used to treat wounds, respiratory infections, and diarrhea. Honey is also used to treat stomach upset, tonsillitis, stomach and intestinal ulcers, mouth and mucous membrane disease, and wound dressing. So these are the chemical constituents of Trigona honey that include moisture content, pH, total reducing sugar, glucose, fructose, sucrose, and also ash content. Organisms in this study include E. coli and also B. licheniformis. E. coli is a type of bacteria that normally live in intestine. Besides, B. licheniformis, a gram-positive spore-forming bacterial species with significant biotechnological interest. Bacillus licheniformis is used to produce bioactive chemicals that are used in a variety of industry. And now I will explain about methodology of this study that include honey sample preparation. 2 brands of honey were collected, and then preparation of inoculum, then proceed to this diffusion test, broth microdeletion test, and also data collection and analysis.
And now let's move to results and discussion.
The inhibition zone diameter was shown in this table. The antibacterial activity of undiluted 100% and varying concentrations of honey, brand 1 and brand 2 against B. licheniformis were tested using this diffusion method. The inhibition zone is proportional to the concentration of the honey for both brands. As the concentration increases, the inhibition zone also increases. This figure shows the mean of diameter of inhibition zone in unit millimeter of honey brand 1 and 2 against concentrations toward B. licheniformis. This table tabulates the inhibition zone diameter for both brands of honey. The antibacterial activity of undiluted, which is 100 concentration, and varying concentrations of honey brand 1 and brand 2 against E. coli were tested using this diffusion method. The mean of diameter of inhibition zone in millimeter of honey brand 1 and 2 against concentration towards E. coli. The present study was carried out to investigate antibacterial activity of different brands of Trigona honey against B. licheniformis and also E. coli. Moreover, this study was carried out to test susceptibility of these two bacteria to honey brand 1 and 2. Based on the results in this diffusion test, it was observed that undiluted and diluted honey exhibited different levels of inhibition against different bacteria as shown in that table. In general, those gram-positive and gram-negative bacteria not plenty showed susceptibility to diluted honey. This is demonstrated by the susceptibility test, which demonstrate that undiluted honey brand 1 and 2 respond to Bacillus licheniformis and exhibited intermediate reaction. As a result, brand 1 and 2 of honey may be used as a substitute to treat any B. licheniformis infection. However, honey brand 2 did not exhibit an intermediate reaction against E. coli. Only undiluted honey brand 1 did. Furthermore, it was observed that B. licheniformis was more sensitive to undiluted honey, brand 2, as it produced slightly higher zone of inhibition rather than brand 1. Therefore, E. coli was observed more sensitive to honey brand 1, as undiluted honey brand 1 exhibited higher zone of inhibition compared to honey brand 2. Undiluted honey exhibited higher zone of inhibition as observed in this study. Previous study conveyed that undiluted honey exhibited better antibacterial outcome. In this study, both brands of honey were serially diluted with various concentrations from 100 to 1.56%. Based on the results from undiluted to the lowest concentration of honey, brand 1 and 2 displays zone of inhibition. This assumes that both brands contain great antibacterial ingredients inside the honey or influenced by other factors. The variation in the antibacterial capacity in honey, even if produced by similar bee species, influenced by different geographical locations where the honey is collected, seasonal conditions, floral source, processing, storage conditions, the sensitivity of the bacteria to antibacterial compounds in honey, and the age of honey samples. In addition, maybe the bacteria in honey samples influence antibacterial activity. Bacteria inside honey itself have shown antimicrobial activities against pathogenic bacteria. The results of this study also demonstrated that antibacterial activities of two brands of Trigona honey are directly proportional to their concentration, as shown by a marked decrease of zone of inhibition as honey are diluted as depicted in table above. In comparison with undiluted honeys, the diluted honeys for both brands had less antibacterial activity. This result is in agreement with the research carried out by Musa 2012, who studied that undiluted honey samples inhibited the growth of E. coli and other gram-negative bacteria rather than diluted honey samples. Furthermore, another study showed that antibacterial effect of different types of honey is type and concentrations dependent. Then, another possible explanation for these results is the reduced concentration of antibacterial compounds left in honey upon dilution. Even though the exact compounds or factors that are responsible to the antibacterial activity of honey were unknown in this study, it has been well established that the antibacterial activity of honey is contributed by some markers such as osmolarity, acidity, hydrogen peroxide, and other factors non-dependent on peroxide. Besides, OMA 2019 have reported that zone of inhibition in higher dilution of honey would be seen if the antibacterial activity was due to hydrogen peroxide. In this study, there was increment in zone of inhibition against those bacteria at various honey concentrations, this indicating the antibacterial activity of these two honeys due to hydrogen peroxide. However, in this study, there was no observation and measurement of the actual level of hydrogen peroxide formation in honey solutions in order to rule out its contribution to the antibacterial activity. Thus, we assume the formation of hydrogen peroxide in these honeys had occurred. As a result, at this point, it could be partially suggested that the antibacterial activity exerted by Trigona honey brand 1 and brand 2 would be most likely due to phytochemicals or other factors in honey which produce antibacterial effect. Another limitation of this study is that zone inhibition was small and difficult to detect, and it was assumed that the honey sample may contain low levels of compound that contribute to antibacterial activity because these two brands of honey were obtained from commercial stores and not freshly collected. Perhaps the condition, temperature, or storage place of the honey samples slightly altered the honey's capacity. Thus, based the effect showed via this diffusion approach need to no longer to be straight away misinterpreted as the bacteria had been resistant to these honeys. These techniques have significant drawbacks. The gradient and matrix network of the agar used for the experiment cause antimicrobial drugs to diffuse poorly most of the time. Besides, the amount of natural product that will be absorbed onto the disc may be overestimated and the rate of medium diffusion may not be sufficient. The MIC and MBC values of the honeys were determined by this method, broth microdilution method. Based on the table, MIC values of honey brand 2 was found to be at 6.25% against B. licheniformis compared to honey brand 1, which is 12.50%. As against E. coli, all the honeys evaluated MIC values at 50%. Furthermore, the MBC values of honey brand 1 was 25%, slightly higher compared to brand 2, 12.50% against B. licaniformis, whereas MBCs for all honeys were 100%. Result, the MICs and MBCs of the two honey varieties were determined using broth microdilution method. This method was used due to efficiency of this method to indicate quantitative results compared to the distribution method. In general, all honeys tested in the present study showed MICs in the range of 6.25 to 12.50% against Bacillus licaniformis. The honey brand 2 inhibited Bacillus licaniformis at lower MIC, 6.25%, rather than honey brand 1, 12.5%. This shows the strength of this honey, which require low concentration to inhibit the growth of the Bacillus licaniformis. However, the honey brand 1 and 2 inhibited E. coli at a high MIC value, which is 50% for both honey. This indicates these bacteria are less susceptible to both brands of honey. This is mean that these honeys do not have enough strength and require high concentration in order to inhibit the growth of E. coli. However, in this study, the MBC values of both honey, brand 1 and brand 2 against B. licaniformis were 12.50% and 25% respectively. It is interesting to note that MBC value of honey brand 2 was lower in the honey brand 1 against B. licaniformis. This could be an indication that honey from brand 2 is better in its bacterial effect than honey produced by brand 1. In addition, honey brand 1 and honey brand 2 is likely inhibit the growth of pathogens. Those bacteria only showed moderate sensitivity to undiluted or diluted honey when tested using this diffusion technique. However, when honey brand 1 and brand 2 was proceed for MIC and MBC determinations using broth microdilution technique, it can be seen that bacteria showed the sensitivity to honey when the MICs and MBCs could be observed visually. Thus, based on the difference in the results of these two techniques, the results showed by this diffusion method should not be immediately misinterpreted, as the bacteria were resistant to these honeys. This is the limitation in the study that must be addressed. So in a nutshell, the current study has successfully established that the antibacterial activity of two types of honey from two distinct places against the two test bacteria varies. Furthermore, this study also demonstrated that in order to assess the antibacterial activity of honey, the broth microdilution method was more effective than the diffusion approach. However, this research demonstrates the potential for using Malaysian stingless bee honeys as an alternative therapeutic agent and act as antibiotic substitute. There are few recommendations, as the floral origins of honey may additionally play a role in how effective it's far as an antibacterial agent, as the honey become accrued from specific locations. It is crucial to hold the ecosystem by prohibiting human spots like logging, so that can guard the excellence of this honey, because the origins of the floral sources may have an effect on the antibacterial interest property of these honeys. Future studies should compare the hive products of various stingless bee species, flowering times, and their physical-chemical characteristics, such as higher acidity and hydrogen peroxide levels, to confirm the precise conditions that dictate the antibacterial activity of the stingless bee species honey.